Okay, we're going to work on lesson 6.2, which is finding the applications of trigonometric functions. So first of all, in example 1 here, they want us to find side x of this right triangle. So first of all, we need to identify which trig function are we going to use to solve this. So we need to identify which ones we do know. So according to this angle here, which is a 65-degree angle, I know the hypotenuse. And this is the adjacent side here that we're trying to find. So if we were working with adjacent and hypotenuse, that means we were working with cosine. So that means we would say that the cosine of 65 degrees is equal to the adjacent side, which is x, over the hypotenuse, which is 8. And so then to solve this, we just need to multiply both sides by 8. So we take our calculator and we make sure that we are in degree mode. So always check your mode, make sure you're in the right mode. And since I'm in degree mode, then I can just type in 8 cosine of 65, and we get 3.38 would be our answer. So x is approximately 3.38. And so let's go ahead and do example 2 here. We'll just keep going right along here. In example 2, they want us to find the measure of angle theta in this triangle. So they give us all three sides, so we know that sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse. And tangent of theta is equal to opposite over adjacent. So we can basically use any ratio. So if we're talking, if we have angle theta here, then this is our opposite side. The 4 would be our adjacent side, and the 5 is the hypotenuse. It's the side across from the right angle. So we could use any of these. We could use 3 over 5 here. We could use 4 over 5 here. Or we could use 3 over 4. It really doesn't matter which one you use to find it. And I'm going to go ahead and use tangent in this case. So since I know the tangent of theta equals 3/4, to find the angle, now if we know the angle, we would just say tangent of whatever the angle is, and it would give us a ratio. If we're trying to find the angle, that means we're going to do the inverse tangent of our answer, or our ratio, which is 3/4, and that's going to find angle theta for us. So we take our calculator here, and I do second tangent of 3 divided by 4, close my parenthesis, and we get 36.87 degrees. So theta is approximately 36.87 degrees. Now here when we're solving right triangles, that means we're trying to find all of the missing sides. And so we have this chart here that a right triangle can be solved if the following information is given. So case 1, they give you an acute angle on the side, tells you the steps you can go get through them. And case 2, if they give you two sides, gives you the steps to go through to solve them. So you can use both of them, probably depending on the situation you're in. So let's just take a look at these couple of examples we're going to have here. Example 3 and 4 we're going to go over now that involve both of these two types of way of solving right triangles. If we look at our first example here, example 3, it gives us this right triangle that they tell us we have the angle here of 75 degrees, that this hypotenuse is 17, and they have angle theta as our top angle, which we don't know, and then we have sides A and B. So we're trying to find angle theta, side A and side B. So here they give us an angle and a side, and we'll find the missing parts. First of all, if you know an angle, the other angle is the easiest to find because the two angles have to add up to 90 degrees. So in this case, angle theta is 15 degrees. So that's the easiest part. Then we want to find sides A or B. Now the question is, does it matter which one we find first? No, it doesn't. But we're going to use the 75-degree angle. So side A would be the opposite side, and side B would be the adjacent side to that angle. So we can set this up that opposite and hypotenuse is sine, so that we would know that the sine of 75 is equal to the opposite, which is side A, over 17. And let's go ahead and solve that one first. So we multiply both sides by 17, and we get A is approximately, and take out your calculator again. Always remember, if you come back after you've been working on some other stuff, always make sure you check your mode to make sure that it is in degrees. So we'll do 17 sine of 75, and we get approximately 6.42. Was that 16.42? Okay, 16.42. And don't forget, if there's a problem with units, that make sure you do have the units there. Okay, so we have 6.42 there. And now to find side A or side B, the third side, you actually have a choice. You could use the Pythagorean theorem, a squared plus b squared equals c squared. Or you could just use cosine and the fact that we have the cosine of 75 equals b over 17, and we'll multiply both sides by 17 again, and we get, let's see, 17 cosine of 75 equals 4.4, so approximately 4.4. So b is approximately 4.4. Okay, so there's the first example. If we know an angle on the side, how to solve the triangle. And so we had three things that we were finding, so we need to make sure we identify all three of them. So we found that theta was 15 degrees. Side A is approximately 16.42, and side B is 4.4. All right. Now, example 4 here, they give us two sides, and they want us to find the angles. Okay. So we have the hypotenuse in this case is 12. We have angle beta here, and angle theta there. And then they want us to find side A. So we've got those three things we're trying to find. Now let's first, since we know two sides of the right triangle, let's find the third side first. And so to find side A, we're going to use the Pythagorean theorem. So a squared plus b squared equals c squared. And let's see, well, A is the side we're missing, so we can't use that. And so we'll put 6 in for B and 12 in for C. So we get a squared plus 36 equals 144. And we subtract 36 from both sides. Get a squared equals, and let's see, that is 108. And so if I take the square root of both sides, we get a equals, and in this case, we're going to go ahead and use a decimal. And so the square root of 108 would be 10.39. Okay, so this is 10.39 would be our third side then. Now to find angles A or theta and beta, I'm going to go ahead and use the fact that I have the 6 and the 12 here, and I'm going to use those numbers because the 10.39, that's okay to use, but I'd rather use the exact values that I have. So let's go ahead and find beta first, since that's the angle closest to us, I guess. And so I know, according to beta, I know side 6, which would be the adjacent side, and side 12 would be the hypotenuse, so that's cosine. So we'd say the cosine of beta is equal to the adjacent over the hypotenuse. So 6/12. And if you remember from our work in the last lesson, that if I have 6 over 12, that's 1/2. And we learned that cosine equals 1/2 at 60 degrees. So angle beta would be 60 degrees. And we can prove that. We'll go to our calculator and we'll do the inverse cosine of 0.5 or 1/2, and that equals 60 degrees. So then our angle theta then is relatively easy then, because we know the three angles have to 90 degrees, or the two angles have 90 degrees, so this would be 30 degrees. So my answers are angle beta and angle theta are 30 and 60, and side A would be 10.39. And